Algebra 2, Lesson 8.10. We'd like to review a very important concept that we saw at the very start of this unit. And that is, if you're given this exponential equation, b to the x equals y, that's actually equivalent to a logarithmic equation. You might remember the base of the log is the base of the exponent. The base of the log is the base of the exponent. And that can help you out so much in terms of knowing how to convert from this one to the other. I'm going to have the log base b. The power, remember, never goes inside the log. The power actually gets set equal to the log. And this missing piece right here, y, has to go inside. What are we getting at? We can always double check that we're right by making our log circle. You could see we've written this correctly. B to the x equals y. Now, as we're looking at these problems here today, we're going to solve exponential equations. We're going to need our calculator. But before we do anything, we'd like to convert to a log equation. We've got base 3 here, so I'm going to say this is log base 3. My power of 8x will not go inside the log. It's going to be equal to the log. This 4 right here has to go inside. And then sure enough, we're going to be able to more or less just go ahead and check we're right with a log circle. How is this preferable? Well, right now you can see that we need to get our x alone. And I'm going to divide both sides by 8. And guys, right now you'll have what x is equal to, but I'd like to show you something on the calculator. There is a wonderful tool under math. If we go all the way down to log base, we're going to we can enter in whatever log that we'd like. This is the log base 3 of 4. That's really what we're going to have here. And then we want to divide by 8. I could make a fraction with the alpha y equals if I wanted to. There's honestly no need to do that. You can see we will go to the nearest hundredth, 0.15, but when you look to the right, we're going to have to bump that up to 0.16. And then we're done. Let's take a look at another problem here. We've got base 5, so we know we're going to have the log base 5. The power never, this exponent, never goes inside the log. It is the log. It equals the log. This 12 is what's going to go inside. And then you can see very quickly, our x is not alone. But we can get it alone when we divide by -3. So now it's just using the calculator here. I'm going to go to math, and do log base, and I'll do log base 5 of 12. The calculator can get us a decimal approximation, but I'm going to divide that by -3 just as well. And we will get -0.51. Okay, so as we go to number 6, you can see this one's just a little bit different. Of course, we've got a base of 11 for our exponent, so we'll have the log base 11. Our power is a little bit more complicated, isn't it? It's x minus 7. We'll have our 15 in here. And right now I'm going to add a 7 to both sides. So if I wanted an exact answer, of course, these are not like terms. They would look something like that. So let's get our calculator out. Hit math. By the way, if you want a quicker way to get to log base, hit the up arrow. You can get there a little bit more quickly. I'll type in an 11. Type in our 15, exit our parentheses and say plus 7, And guys, it looks like we'll be at 8.13 when we round. 8.13. One more problem, and it actually involves this e right here. Very similar problem to what we were just doing. This is going to be the log base e of, well, our power is y minus 7. And then we'll have our 15 in here. But we know that the log base e of 15 is actually the ln of 15. And then we can just add a 7. And the official answer would be natural log of 15 plus a 7. And we can get that typed in. You need to close parentheses, though. This is the end of your log. And we'll type plus 7. And we should get 9.71 as we're going to the nearest hundredth. So that's all for this lesson today.